The topic we are going to discuss today is Brocchistochron. Brocchistochron is a solution to the problem posed by Johann Bernoulli in June 1696. He said in a letter to the world, "I, Johann Bernoulli, address the most brilliant mathematicians in the world. Nothing is more attractive to intelligent people than an honest, challenging problem, whose possible solutions will bestow fame and remain as a lasting monument. Following the example set by Pascal, Fermat, etc., I hope to gain the gratitude of the whole scientific community by placing before the finest mathematicians of our time a problem which will test their methods in the strength of their intellect. If someone communicates to me the solution of the proposed problem, I should publicly declare him worthy of praise." In short, he just hoped all mathematicians in the world to solve the problem with him, and he'll be very thankful for this. And then he defined the problem as given 2 points A and B in a vertical plane. What is the curve traced out by a point acted on only by gravity, which starts at A and reaches B in the shortest time? And we should be noticed that it should be in the shortest time instead of the shortest path. So the problem we just mentioned is called 最速降线问题 in Chinese. And the solution is Brocchistochron, we mentioned already. Brochistos and Chronos is Greek, they're not English, and their meaning is shortest and time, respectively. And in the below, I showed again the definition of this problem. 最速降线问题. Okay, so again, I showed you that Brochistos is shortest and Chronos is time. So to illustrate this problem, we have to talk a little about earlier research from Galileo in 1638. Okay, so he solved a problem that the conclusion is the quickest path of all something from one point to another is not the shortest path, namely a straight line. It's not a straight line, but the arc of the circle. So the nearer the inscribed polygon approaches the circle, the shorter is the time required for descent from A to C. What has been proven from the quadrant holds true also for smaller arcs. The reasoning is the same. Go back to the problem that Johann Bernoulli posed. So 5 mathematicians responded with solutions in the end, include Johann himself, Newton, Jacob Bernoulli, Gottfried Leibniz, and L'Hopital. Johann Bernoulli's way is according to Fermat's principle. The actual path between 2 points taken by a beam of light is one that takes the least time. He used this principle to prove the problem, and in 1697, Johann Bernoulli derived the Brocchistochron curve by considering the trajectory of a beam of light in a medium where the speed of light increases following a constant vertical acceleration of gravity g. And that's go for Jacob Bernoulli. Jacob is Johann's brother. He showed that how second differentials can be used to obtain the condition for this time. He also used Euler's calculus of variation. So what did they got for the answer? They all got the same answer, which is cycle width. What is cycle width? Cycle is the fastest path for the ball to roll. What does it mean? So we consider a plane and a ball on it, and now we consider a fixed point on the ball. Now we start to roll the ball, and now we follow that fixed point we plot, and then the trajectory that the point generates, that is what we call a cycloid. What can cycloid do in our real lives? So in roller coaster, downhill skier, or surfing, we can all use this phenomenon. Since when we are taking a roller coaster or we're skiing, surfing, what we want to have is a sense of excitement. So cycloid can let us to achieve the fastest rate in the shortest time so that we can achieve our goal.